Right. Let's see. We have reverse integer, and this is a problem that actually I was working on a few days ago, and I just never got around to finishing it. I think I beat like 1,000 of the 10 cases. Of the test cases. I was just missing like 10, just because of one specific condition. But here we go. Given a signed 32-bit integer x, return x with its digits reversed. If reversing x causes the value to go outside the 32-bit integer range, then return 0. Assume the environment does not allow you to store 64-bit integers, signed or unsigned. Okay, so we have so for example, if x is 1, 2, 3, then we take 3, 2, 1. If x is negative 1, 2, 3, then we take negative 3, 2, 1. Makes sense. So let's see what my solution was that I was working on. I didn't comment it. Remind me to comment my LeetCode solutions, but then again, it doesn't save them for the most part. But anyway, we have reverse. So the first thing I did was I realized that if you're gonna reverse the number, you kind of had to worry about maybe like the system I came up with to handle negative things was to just take the negative out of the equation, and then I could just add it back in with a little toggle. Um, so let's see. So I have the backwards number, and then let's see what I do. First off, I take out the negative. I take the negative out of the equation, and then I make a copy of that number. And yeah, then basically I x copy equals x copy floor divided by 10. Is that just to get oh yeah, this is just to get the number. This doesn't save anything other than the multiplier. This is just to get the number of um, digits in the number so that when we iterate back through this, we have a number array and we append each so we take the modulo 10, so that'll be the first digit in the number, and then we multiply that by the multiplier. So that's basically, it's hard to describe, but so like if we have 1, 2, 3, 4, so this right here just iterates through, it divides it by 10. Now we get floor divides by 10, so we get 1, 2, 3, 1, 2, 1, and then 0. And then all the while, the multiplier gets turned up to 1, 2, 10, 1,000. So we have the multiplier at 1,000. All right, and then we have the num array. Let's see. And then yeah, so this will give us all of the numbers in the different decimal places, starting with the well, actually, well, it doesn't really matter what it starts with because they all get added at the end. But yeah, so the multiplier is set to 1,000 right now. So we take the lowest number by taking modulo 10 of x. So if x is 1, 2, 3, 4, then modulo 10 will give us 4, and we multiply that by the multiplier, and that will give us 4,000. Remember, the initial number would be 1, 2, 3, 4. So now we have 4,000, and then we divide the multiplier by 10. So then we do the modulo of let's see, modulo. So then we floor divide 1, 2, 3, 4, and we get 1, 2, 3. Modulo 10, now we get 3, and the multiplier is now 100, so it's 300, and so on until we get 4, 3, 2, 1. We tack on the was it the negative toggle at the end? So if we took out the negative toggle before, I actually don't know if we need to do that. I think it's just easier to do that. Just take the negative out of the equation, because what was it? Yeah, just because I'm adding the numbers together. I don't really think it matters, but I also don't think that one toggle will matter that much for the runtime. So I'm just gonna leave it in there because it's close to working. But anyway, the only thing that's not working is that it doesn't deal with numbers that are outside the 32-bit range. So I'm just gonna say like if int Okay, let's see. We'll say results equals int backwards num. I forget why I did the int. I actually don't think I need to do the int. Yeah, because that's just a number. If backward, I think I was just trying to do that because I thought it would like limit the 32-bit signed integer range, but I don't know. Okay, so if backwards num is greater than 2, it's 31 minus 1, or if it's less than negative 2 to the power of 31, then return 0. Otherwise, just return backwards num. Does this work? I don't know. I'll be frustrated if it doesn't. Oh my goodness. Oh, yeah, I did int because it's a floor because of the multiplier earlier being 0.1. Or sorry, it's a float, not a floor. Woo, 60%. We take those. All right. So a little goofy solution, kind of messy, but gets it done. How did that that snuck in there? That was funny. Yeah. Okay, 60%. A medium problem done. Awesome. Thanks for watching.